Namaste! Today I did the CS50 week 4. I of course want to do one of the hard versions and then just one of the normal ones. So I did the more comfortable version of filter, and then I did the recover projects or problems. So let's just head into filter. Filter is a problem where you need to, modify an image in 4 different ways. You need to make it grayscale, reverse it, blur it, and edge it. And you'll see in the examples how I do it. So let's just head into the program. First, we wanted to grayscale it, so let's just do this grayscale thing here. I think it was G. That file is gray and very large, so that you make it a little smaller. So the challenge here is to make every pixel in the area the mean of all the different of the red, the green, and the blue. So it's pretty simple. A picture is basically a 2D array, a struct 2D array, and every position or node, or what you call it, has RGB value for red, green, and blue, and that's what we are gonna play with in these 4 different versions of the photo. So the first one, I just make a normal for loop for a 2D array. I have the height of the photo and I have the width. And then, to make it gray, I just take the value of the red, the green, and the blue, and I take the mean of them, so I divide it by 3, and then I set those new values. And that's how you make an image grayscale like this. It's pretty simple, pretty easy. Then we move on to something a little more hard. So it's time to reverse it. So let's see here, I think it was the R. Let's see. Yeah, it reverses it. We can actually take the normal picture here too. See the normal and the reverse version. How you reverse it is basically, how can you say it? You need to make, I made a temporary array. And in that temporary array, I just place everything on the column row in the opposite spot. So if it's in the last spot, it should be in the first spot, and then you just make it simple with -J and width. So it's very easy, and then I just assign the new values to the input with the temporary array. And this one I will use a lot for I will use a temporary array for all of my for this one and the next 2 changes as well. But yeah, it's a reverse horizontally, so I only needed to do it in the rows, and it's pretty I only need to do it within the columns, what you call it. These 2 are pretty easy. Then we get into the hard stuff. I can actually take this down in the meantime. The blur one is a lot of lines of code. There's probably some better ways to do it, or 100% there is better ways to do it. Oh, that's the original, that's the blur. But how the blur worked is that you take let's see here, let's head down. You take the average from, or wait, let's just bring up the website so it's easy to see. Maybe we can, he has a good example here.
The next filter that you'll implement.
We don't need to listen to him. And here you see. Okay, so for each pixel, you take the value from all of them. Okay, let's see here. Yeah, I want to blur. So for each pixel, I take every pixel around it and the center one, the one you are on. You take the value from the red, green and blue from all of them and take the mean. So that's what you do for every pixel, which for me was a lot of code and a lot of variables. Okay, the annoying part is just the edges, the corner and the sides. So first I just have the variables. So I have the variables for each pixel. So if I am at position I and j, so let's say this is position 1, 1, so almost up in the corner, left corner. Then the top would be I minus 1 and still the same name in the column. And the bottom will be plus in the height, so in the I. And then we have left, which is just the same row but different column. And upper left is, one row up, and upper left, let's see here, I think I've done wrong here. Oh, I have. Okay, this upper left corner should, no, sorry, I have done right, sorry. Yeah, and if you take the upper left, it's a minus 1 in the height, because that's how you iterate. How do you say it? Iterate. That's probably it. Because you iterate from 0, which is the top, and then to the height, which is at the bottom. So yeah, everyone is just in the grid. Think of how it works from my examples from here. So first I just set the variables, and if they are at specific positions, because otherwise I will get a segmentation arrow. I can't get the left pixel if I am at the left wall, because there is no pixels to the left, and so on. Then I start doing the calculations. So for if it's a bottom corner, so I basically have an if statement to where we are in the picture. So for every corner and corner and wall and stuff, they have their own specific calculation, and they use their own specific variables. And then of course I have my center one. So if I is not equals 0. How the calculation work is, like I said before, you take all the pixels in the middle and all of them around it, then you take the mean of all of them, and you have to round it, otherwise it won't work. And then I just process the new values from the temporary array to my image. So it goes from this, takes every pixel, goes like this the whole way down and blurs. The last one is the edges. So let's do the edges one. Edges are very similar to the blur, but a little bit more, how can you call it, advanced or annoying. So let's see here. I think he had some good photos here as well. We have here, yeah. So before you took the mean of every spot. Now instead you take -1 times the value, 0 times the value, so you go for the x and the y values for all the pixels. So it's basically the same as blur, you just do a different kind of calculation. And I have almost the same look of it. The difference now is the calculation. So let's see here if we can take them the normal middle, not the left wall, blah blah blah. Here, normal spots. So as you see, it's a lot of things. Maybe I can turn it around a bit here. Shoof. So for each, for the x values, let's see here, I have the upper left corner, -1 times that, -2 the left corner, -1 the lower left corner, top 0, and so on. I follow this grid as they want me to, and then I do the same for the y. So that's it. So upper left corner is now still -1, but the left corner is let's see here, here is wrong, this should, no, that's correct, sorry. -1, then 0, then 1, then -2, the center is always 0, and so on. And then you have this very weird calculation, because now it's not the mean of them, it's something different. So now you have this large value here from all the values. Then you square root them and you add them together. So you square root the x value and the y value, and then you square it and round it, so you get the kind of value that makes sense. And then you do it for the red, green and blue, for every pixel of course. And then you have this, I have this if statement here. So if red is larger than 255 and green is larger than 255 and so on, that's not good because it doesn't exist. So instead, if red is larger than 255, you just cap it at 255. And same for green and blue. And otherwise it's just the normal values. And that's it. Then you just copy over the new values to the image. Bam. This challenge took me like this part went pretty quick with the edging, but first, that's a mad dog outside. I just had problems, some stupid problems in the blurring one, where I had forgot to have if statements for my variables. So if I was at the top left corner, I got a segmentation fault because there is no pixel to the left or up, or so this was the filter more. Took a lot of time, but I had stuff to do in school, so but it should be faster. Sometimes you're with this much lines of code, I get a bit confused, but I need to look up how short you can actually make this code. Okay, let's see here. So that was the filter more. Let's move on to skip this CD. I have the recover. CD recover. In recover we have a raw file, and I have from the start basically an empty file, which we haven't had in a long time now. CS50. And what this file, what this program needed to do was to find JPEG files in this raw data file. So in here there are about 50 images, and I needed some way to recover them. In the YouTube video for recover, we got a pretty good explanation on what to do, but I got confused in multiple ways, so it took me probably like 5 days to figure out what the different file openers and blah blah is. But now finally today I managed to do it. It took a lot of time and a lot of googling and a lot of YouTube videos on raw files and file management in totality. So let's see here. I need to use this one. As you see here, paste there. I don't need to see this one. And okay, when I run this, I will get 50 images. See, they're very small and cute. Maybe they should be larger, hopefully not. But yeah, I get 50 images. Let's just remove those images. I'll do it later maybe. In the YouTube video we got a good basis on how to structure the program. So first we needed to open the memory card, or my memory card, open the card.raw file. Now when that's open, it's time to get out the pictures. But first I need to make variables. I have a buffer to store bytes, which I talk about later. I have a file number thing, iterations, and file name and image. Why we have a buffer is because the next step is to read what's in the raw file. So this while loop works so if every time I can open a 512 size block from the file, it will continue, and I have access to those 512 bytes, and I can hopefully store them in a JPEG file. Well, that's why I have this buffer. Why do I use the byte thing here? That is because I use the unit uint8_t, which for some reason, and they gave us a hint on the website, makes it so I can read the values in the buffer or in the file. Because to get to the JPEG file you need if statements, and the if statements are very specific, because for a JPEG file they have the first 3 bytes have a specific value. So the first one has OXFF, the second one has OXD8, third one has OXF, and the fourth one has everything from OXF0 to OXE, no, OXFF or something. And in the YouTube video, they showed how we can use this to get all of the 14 values, or just the first 4. I need to work on this one a bit. But I have this while loop that reads 512 bytes. If the 512 bytes start with this, I can start working on the file. Now if I find a JPEG file, I first see, let's take this later. I need to make a new file, a file name to store it. So that's where this variable is. It has 8 in size, which took me a long time to understand that it's just a name. I thought it would be the file name for just the whole picture. But yeah, so it's 8 characters, because we want it to be 0.28 028.jpg, and so it's basically 8 characters with the \n as well, or no, the null. Let's skip that. The name is 8 characters long, so that's what this is. Make the name. I make the name larger for each time I make a file, otherwise they would all be called the same and overwrite probably. Then I open the image file, which has and I write to it here, and what I write is the buffer size. So I write 512 bytes to my image, but it doesn't stop there, because probably the JPEG isn't 512 bytes large. It's tiny picture then. So I will continue and write 512 bytes again and again and again and again until I find another JPEG and I need to stop. So here, if I found a new JPEG, I will close the previous one, make a new file, and write to that. That's how it will work. So it will just loop through the whole byte and the whole raw file. If you find JPEG, it will start right to the image file, call it 0.00.jpg and continue like that until the data, the raw file, doesn't have a 512 byte block size left. And in the end, you of course close the files. This challenge was damn hard, but I had more time for this one during the day, so it took me a little bit faster. So yeah, a lot of googling on what I should open, because of course they don't tell you everything in the YouTube video on the website, so you need to do a lot of thinking by yourself. Yeah, well, thank you for listening. Have a good day, and adios amigos, whatever. Goodbye.